Today we're going to do relations and functions. This would be a good time to pause and copy the vocab. This is a review of what we've already done last semester. If you're new, then you may not have seen this before. One way or the other, you need to copy this. This is part of the 56 to 75% of the EOI, so you do need to know what these mean. Sorry about my voice, I'm sick. So domain is the input value or the X value. The range is the output value or the Y value. Relation is a set of ordered pairs, and function is a set of ordered pairs in which each X value has only one Y value. Remember, the function is where one person can only be in one room. So you can have more than one person in a room, but only one person can be in one room at a time. And then it would be a good time to go ahead and pause and copy this. Okay, all of you should have it copied. This is just a set of ordered pairs. So this whole thing is a relation. In red is your domain, and in blue is your range. I have it identified, your X value, your Y value. So domain, I've listed them in order numerically: -4, -3, 2, 4, 9. And in the range, -3, -2, 0, 3, 6. The relation is a function because none of the X values have more than one Y value. And so what that means is if I were to go ahead and highlight, if the computer wanted me to do that. Okay, so if I highlighted the X values, I want to go ahead and make sure that none of these numbers are the same. I do have a 4 and a -4, but those are not the same values. So none of these numbers in red or highlighted are the same number. So this is a function. Okay. So again, this would be a good time to pause and copy. Okay, everybody should have copied by now. The directions are the same in your packet that you get after the notes. It says identify the domain and range and tell whether the relation is a function. So the first one that we have, you have your X values and your Y values. So what you want to go ahead and do first is list the domain and the range. So we're going to go ahead and try to find, we want to list the domain and the range. The domain is going to equal 3, 1, 3, 1, 2, and 4. The range is going to equal 5, 0, 4, 9. And then we want to know, is it a function? Sorry, guys. So what we want to do is here we want to look at our X values, and each X value only has one arrow or line coming out of it. So each person is only in one room. So it would be a yes. So down the second one, your domain is going to be 1, 2, 9, and your range is going to be -3, 0, 1, 9. And then we want to know, is it a function? So what we want to do here again is we want to look at your your Y value, and then what you want to do is, since it's in a mapping, these two would be your mapping. you want to look at each x value and see that there's only one arrow coming out of it. So person 1, or number 1, is going to 0. But then here you look at your number 2, and number 2 has 2 arrows. Number 2 is trying to go to -3 and 9, and this is not possible, because when you're thinking of number 2 as a person number 2 can't be in 2 different rooms at once. So your answer to this one would be no. Okay, so for these you don't have to copy. I'm just going to go ahead and talk about them. You can list the domain and the range, which you're going to have to do on your packet. And so how you do that is what you might want to do is go ahead and just list the ordered pairs first. And so here, this one, remember, you go to the origin, you go left or right, and then you go up or down. So I'm going to the left, -4, and I'm going down, -2. The next ordered pair, I go to the left, -2, and I go up 1. I go to the right 1, and I go up 3. I go to the right 4, I go up 1, and then I go to the right 5, and I go down 2. So for this one, what you have to do is, you again want to go ahead and list your domain and your range. So I'm not going to put it in order. I have a -4, a -2, I have a 1, a 4, and a 5. My range, I have a -2, a 1, a 3. The 1 appears a second time, so I'm only going to list it once. And then I have a -2, which appears again. So if you have numbers that appear more than once, you only list them once. So then you want to go ahead and look at your points. You can do it 2 different ways. You can look at your ordered pairs. Your first number. None of them are the same, so we know it's a function. Or what you can do is you can look the vertical line test, which we'll talk about here in a minute. But if I were to draw a line for each of the points, a vertical line, none of my green lines should have more than one dot, more than one point on it. So those are all yes. Same thing for the next one. You would list your ordered pairs, and then to decide if it's a function, you can either look at the x values, or you can draw a line through each, a vertical up and down line for each ordered pair, each point on the graph. And here I see that one of my lines has 2 dots on it, so this would be a no. Okay, this would be a good time to pause. Okay, so express as a mapping, then state the domain range, and if it's a function. Okay, so all I did was drew 2 boxes and put my x values in the left and my y values in the right. As you can see, the y values have less numbers, but that's because I had numbers that repeated themselves. So since I had 2 1s and 2 3s, I only wrote the 1 and 3 1s. That's the only way the mapping works. So from here, I'm going to go ahead and draw arrows. I know 2 goes to 1, 0 goes to 3, -7 goes to 8, 8 goes to 3, and 3 goes to 1. So, there's a lot of arrows going on, and there's arrows going to the same number. But again, all you care about to tell if it's a function or not are these numbers and these arrows. Each of these numbers only has one arrow, so the answer would be yes, it is a function. And we've listed the domain, we've listed the range by mapping, and we've told it to yes. Okay. The next one is the vertical line test. This again, you don't necessarily have to copy it. If you want to, it would be a good time to pause. You could just kind of jot down each picture. But you're going to use the vertical line test just like before. Anywhere on the line, if you were to draw a vertical line, the graph that's been drawn, this black line should never touch the vertical line more than once at any given moment. So this would be a function. The next one here, if I were to draw a vertical line here, it touches 2 times. It touches here, and it touches here. So since it touches twice, this is not a function. This is no. I could draw another line somewhere else, and again it hits it 2 times. Okay, the next one. I go ahead and draw arrows, my vertical lines for all the points. And here, I can see that I have one line that has 2 points. So this would be no. And then obviously most of you could tell by the circle, anywhere you would draw a vertical line, it's going to hit it more than once. So this is a no. This would be a good time to pause. Okay, so for the first one it says, when f of x equals 3x plus 2, what is f of 3? So what we're doing is, in a sense, replacing the x with the number 3. And so inside of the expression, we're going to replace the x with the number 3. So here's the problem. F of 3 equals 3 times 3 plus 2. You may use ordered pair. So, order of operations. So you're going to multiply first. You're going to get 9 plus 2. And then that's going to equal 11. You're going to do the same thing here. You're going to end up with g to the g of negative 4 equals negative 5 minus 2 times, says x becomes negative 4. Order of operations says you multiply first. 2 times negative 4 is negative 8. Remember, 2 negatives make a positive, so I end up with a negative 5 plus 8, which equals 3. Do the same thing down here. Okay, so for find the range of the function for the given domain, I've done it all for you already. I'll talk you through it. What you're going to go ahead and do is you're going to write your first one using negative 3. F of negative 3 equals, instead of negative 5x, it becomes negative 5 times negative 3 plus 1. Order of operations, 15 plus 1, which is 16. Same thing for the next one. Go ahead and pause and go ahead and work out the last two. Okay, so you should have gotten the next one, negative 5 times negative 1 plus 1, which is 5 plus 1 equals 6. 5 of 0, f of 0, negative 5 times 0 plus 1 ends up equaling 1, and f of 2, negative 5 times 2 plus 1 equals negative 9.